The topic is what is a service mesh, east-west traffic versus north-south traffic, what is a Istio Service Mesh and core features offered by Istio and how it works. We will learn what is sidecar containers, Envoy and Istiod, and also what is Kubernetes API server with respect to Istio and admission controllers and dynamic admission controllers. But before we begin, hi, this is Kev. I have been a recruiter in the past. Now I have moved into DevOps from scratch. This is part of my transition series. You are making the same switch. Stick around. So first, let's understand what is a service mesh. A service mesh is a dedicated infrastructure layer built directly into a containerized application to handle secure, fast, and reliable service-to-service communication. In a traditional monolithic application, functions talk to each other internally. In a microservices architecture, applications are broken down into tens or hundreds of independent services that must constantly communicate over a network. Managing this communication directly within the application code, for example, writing custom code for retries, encryption, or login, creates massive technical debt. A service mesh offloads these operational complexities from our application code down to the infrastructure layer. First, let's understand what is monolithic architecture and microservices architecture in application development. Monolithic is a traditional or old way of building applications. That means application is of a single service that doesn't have any breakdown of its services or functions, meaning the application itself is a single build code. Whereas for microservices architecture, application services and its function are differentiated and are broken down into tens or hundreds of independent services that communicate constantly over a network. This is really great for managing services and reducing the technical overload of applications. But managing this communication directly with the application code, meaning we aiming to write custom code for encryption, logging, retries, and networking, this creates massive technical debt over the developers. So a service mesh will offload these operational complexities from our application code down to the infrastructure layer by adding an infrastructure dedicated layer directly into the containerized application to handle secure, fast, and reliable service-to-service communication. Here, service is microservice architecture that is broken down into tens or hundreds of independent services that must communicate with each other to let the application work. Now let's understand what is east-west traffic versus north-south traffic. To understand network traffic in a cluster, engineers categorize it into two main directions. North-south traffic. This represents traffic moving into and out of the data center or Kubernetes cluster. For example, an external user accessing a web application from their browser enters through an ingress gateway that is north to south. Whereas east-west traffic, this represents traffic moving entirely within the cluster between our internal services. For example, our front-end services requesting data from the authentication service or the authentication service communicating with the payment service. Key thing to note here is that a service mesh is specifically designed to manage, secure, and monitor east-west traffic. So north-south traffic simply is the traffic from outside of the data center or the Kubernetes cluster. For example, an external user accessing web application from browser enters through an ingress gateway that is called north to south, meaning it is external to internal. And east-west traffic is internal traffic within the services. It is the traffic that is moving entirely within the cluster between our internal services. For example, our front-end service requesting data from authentication service or authentication service communicating with the payment service. And service mesh is specifically designed to monitor service-to-service communication that is called east-west traffic. Now, what is a Istio Service Mesh? Istio is an open source production ready service mesh that integrates transparently with cloud native applications. It acts as an underlying control plane that manages how data is routed and secured between our services. So we understood the concept of service mesh. Now, Istio is an open source production ready service mesh platform that integrates transparently with cloud native applications. It acts as an underlying control plane that manages how data is routed and secured between our services. What are the core features offered by Istio? First is mutual TLS or MTLS. TLS means transport layer security. By default, the internal cluster traffic is unencrypted, which is HTTP. Istio automatically upgrades service-to-service communication to MTLS, that is Mutual Transport Layer Security, without requiring us to change a single line of application code. We must know that all the services and everything we deal with Istio or Service Mesh is related to internal communication, which is east-west traffic. So here the same concept of a TLS, that is Transport Layer Security, which is mutual, is internal services that are by default unencrypted, which is HTTP. So there must be certain services or service mesh that would automatically upgrade it to secure, which is HTTPS. So Istio is a service or open source platform that automatically upgrades service to service communication from unencrypted HTTP to MTLS, which is Mutual Transport Layer Security, without requiring us to change a single line of application code. It handles automatic key and certificate generation, distribution, and rotation. It ensures that both client and server verify each other's identity before exchanging data, preventing man-in-the-middle attacks within the cluster. Usually when we hear about TLS, we think of it as north-south traffic, which is external user accessing the application. But here in Service Mesh or Istio, it is east-west traffic, which is service-to-service internal traffic. While we implement HTTPS or TLS for north-south traffic, which makes it HTTPS, it is same. We also implement HTTPS or TLS, transport layer security, but for east-west traffic or service-to-service communication. Here Istio handles automatic key and certificate generation, distribution, and rotation, and it ensures both client and server verify each other's identities before exchanging data, preventing man-in-the-middle attacks within the cluster. So all of this communication, encryption, security happens behind the scenes, where there must exist a handshake between services to verify its certificates or identities of TLS before exchanging data or communicating with each other, that prevents man-in-the-middle attacks within the cluster. Second is ease of advanced deployment strategies. Istio makes complex deployment patterns remarkably simple by managing traffic routing rules at the network layer, which, for example, canary deployments, we can deploy a new version, that is version 2 of a service, and use Istio to route precise 1% or 5% of live traffic to it. Once verified, we can scale it up smoothly. Blue-green deployments. We can keep the old production environment, that is blue, and new environment, that is green, fully isolated, then instantaneously switch 100% of the traffic to the new version with zero downtime. First, we must know that there are certain deployment strategies in Kubernetes like canary deployment, blue-green deployment, and rolling update. These strategies ensure that when an application is upgraded from a certain version, there must exist zero or near zero downtime and zero or near zero risk and minimum resources taken to achieve it. So Istio manages these advanced deployment strategies and makes it efficient and easy to manage. How it does? It makes complex deployment patterns simple by managing traffic routing rules at network layer. For canary deployment, we can use Istio to precisely route traffic 1% or 5%. Once it is verified, we can scale it up smoothly. For blue-green, it is to switch from blue to green and to route 100% of the traffic to the new version with zero downtime, or if it has some bugs or errors, and to switch it back to the blue or the old version with 100% traffic with near zero downtime. Smart observability with Kyali. Kyali is a management console specifically built for Istio. It acts as the visual dashboard for our service mesh. How Kyali benefits teams. It provides live topology graphs. It visualizes our entire microservices network in real time, showing exactly which services is talking to what. Traffic health at a glance. It color codes service relationships based on HTTP status codes, for example green for 200 OK and red for 500 server errors. Performance metrics. It integrates with Prometheus to display latency, request rates and error rates directly on the visual graph. For configuration validation, it analyzes our Istio configuration files for errors, helping us catch misconfigured routing policies before they break production. Now let's understand how Kiali works with Istio in solving observability and monitoring of application. We know that we use Prometheus, Grafana for monitoring and observability for visual dashboard, etc. But by default, it has empty panels and dashboard for observability, where we manually create those PromQL dashboards, which can take time to build it. So Kiali solves it by providing visual dashboard for our service mesh that is way better than manually creating dashboards or observability. It provides live topology graphs, traffic health at a glance, performance metrics, configuration validation. Simply, it provides dedicated smart visualization and observability with respect to our services and service mesh. So that was about Istio Service Mesh and its core features. Now let's understand how it works, meaning what are sidecar containers, Envoy and Istiod. Istio splits its architecture into two distinct parts, which is the data plane and the control plane. First is the sidecar container Envoy proxy. Instead of forcing our application code to handle routing and encryption, Istio injects a lightweight proxy called Envoy into the same pod as our application container. This companion container is known as the sidecar. So instead of forcing the application to handle routing and encryption, which is MTLS and other benefits offered by Istio, or service mesh concept of east-west traffic management, here Istio injects a lightweight proxy called Envoy into the same pod as our container. That would mean our application would have two containers, and this companion container is called as the sidecar. This sidecar container or Envoy proxy will help in routing, encryption, deployment efficiency, and Kiali monitoring and other benefits as well. Second is the shift in request flow. Before a service mesh is introduced, container A calls container B directly over the network. With Istio implemented, the request flow changes completely. Container A initiates a request to container B. The network traffic is transparently intercepted and redirected into container A's Envoy sidecar. Then the sidecar A establishes an encrypted MTLS tunnel with sidecar B. Then sidecar B receives the encrypted traffic, it decrypts it and passes it locally, that is over the local host, to the container B. So we must know that before Istio was introduced, our container was directly communicating with each other, meaning container A calls container B directly over the network. But when Istio or service mesh concept is introduced, that request flow changes completely, meaning now container A will not directly communicate with container B. When a container A initiates request to container B, the network traffic is transparently or behind the scenes, it is intercepted and redirected into the container A sidecar container, which is Envoy. Then sidecar container A establishes an encrypted MTLS tunnel with sidecar B. Then sidecar B receives the encrypted traffic, it decrypts it and passes it locally to the container B. Before it was container to container communication, now it is container A will try to initiate the communication with container B, but it will not happen until container A's sidecar container network traffic is intercepted, which is redirected into its Envoy sidecar container. Then container A's network traffic is encrypted to proceed communication with the container B. When it reaches container B, it first communicates with the sidecar container of the container B. When sidecar container of container B receives that encrypted traffic, it decrypts it and passes it locally to the container B. Before it was direct container communication, now the communication is through sidecar containers to implement MTLS, that is mutual transport layer security. Because Envoy handles this handshake, our application containers believe they are simply sending and receiving standard and encrypted HTTP traffic. This interception allows the sidecar to reliably enforce timeouts, handle retries, and execute split traffic deployment strategies like canaries, regardless of what language the underlying application is written in. One more thing to note is that here the word intercepted and redirected is mentioned. There is a purpose and reason to mention this word. Without Istio communication of containers, which is container to container, it was Kubernetes API server communicating with etcd for pod communication. Now with Istio Service Mesh, that etcd step is intercepted by sidecar containers. Now third is centralized control with Istiod. While the Envoy sidecars handle the actual data plane or the data, Istiod acts as the brain or the control plane. Istiod does not touch individual application request. It acts as a central certificate authority to issue MTLS certificate to the proxies. It translates high-level routing configurations into instructions that Envoy can execute. It collects telemetry data and metrics tracked by the sidecar containers, passing them downstream to monitoring tools like Prometheus and Kiali. Simply, all the benefits or services offered by Istio Service Mesh can be considered as data plane, and Istiod is the brain that is control plane, meaning Istiod does not touch application request. It acts as a central certificate authority for TLS certificate to the proxies. It translates high-level routing configurations into instructions that Envoy sidecar containers can execute. It helps in collection of telemetry data and metrics that is tracked by sidecar containers, then passing them downstream for monitoring tools like Prometheus and Kiali. So Istiod acts as the brain that is the control plane. Now let's understand Kubernetes API server with respect to Istio Service Mesh and what are admission controllers or dynamic admission controllers. To inject these sidecar containers automatically without manual user intervention, Istio relies on 4 extension points within Kubernetes. So what is an admission controller? An admission controller is a piece of code that intercepts requests to the Kubernetes API server after the request is authenticated and authorized, but before the object is persisted into the cluster storage etcd. So I mentioned before about interception and redirection. Kubernetes admission controller is responsible for implementing that or making it work, as admission controller is a piece of code which helps in interception of request to the Kubernetes API server, and after that request is being authenticated and authorized, before that object or communication exists between the clusters etcd storage. Simply, they act as the gatekeepers. For example, an admission controller can reject a pod deployment if it violates security compliance rules. Now, what is a dynamic admission controller? A dynamic admission controller allows developers to extend Kubernetes capabilities using webhooks. There are 2 types of dynamic admission controllers. First is validating admission webhooks that can read the request and either accept or reject it. Second is mutating admission webhooks that can read the request and modify or mutate the configuration on the fly before it deploys. Without Istio or Service Mesh, communication in Kubernetes API server would communicate with etcd. Now, while we implement Istiod Service Mesh or Istio Service Mesh, that flow is intercepted, and now it is Kubernetes API server first communicating with admission controller, which is intercepted before the etcd communication or before the object is persisted into the cluster storage etcd. So after it is intercepted, it has certain superpowers in the sense of either accepting the request or rejecting it, or to read the request and to modify or mutate the configuration on the fly before it deploys. In short, it is like we are adding a barrier between direct communication of etcd and API server. Now it is API server first communicating with intercepted dynamic admission controllers configuration, then it reaching to the etcd, not directly. By doing this, we are extending Kubernetes capabilities by adding validating admission and mutating admission webhooks that helps in either accepting or rejecting the request and to modify or mutate the configuration before it is deployed. Now let's understand how this actually works, meaning auto injecting sidecars. Istio utilizes a mutating admission webhook to inject sidecar containers seamlessly. As I mentioned, there exist 2 types of dynamic admission controllers. One is validating and second is mutating. For sidecar containers injection, mutating dynamic admission controller webhook is utilized by Istio. How it works? First, user or the CI/CD deploys standard one container pod manifest, which is Kubernetes API server, then communicating with Istio mutating webhook. How it inspects namespace for Istio injection is equals enabled label. If this label exists, then mutating admission controller webhook takes place, providing sidecar containers. If this was not enabled or present as a namespace, then it would be a normal pod-to-pod communication without sidecar containers. Then manifest of the pod is updated dynamically without us trying to update it, which means injected pod manifest, which means it adds Envoy proxy container, that is sidecar container, plus init containers to manifest. So after it inspecting or finding Istio injection is equals to namespace label, it injects or adds Envoy proxy container. So now we have both containers, which is init containers of the manifest of which we have provided, and new container or sidecar container added in the file, which is envoy proxy container or sidecar container. So this were the steps between Kubernetes API server finding or inspecting namespace Istio injection enabled before it even reaching persisted etcd and scheduled. So if Istio injection would not be present, it would directly communicate by Kubernetes API server and persistent etcd and scheduled. Now as it inspected or found out Istio injection is equals to enabled, which is Istio mutating dynamic admission webhook, it intercepts and modifies the manifest file dynamically by adding another sidecar container into it. So now we have two containers. After all this, it reaches persisted to etcd and scheduled, which means pod spins up with two containers running inside it. So again, if it will not find the Istio mutating admission controller webhook or simply Istio injection that is enabled label in the namespace, it would be direct Kubernetes API server to persistent etcd communicating with each other. Now as this namespace is inspected, the communication between them is intercepted by Istio adding or intercepting mutating dynamic admission controller webhook, which modifies the manifest file dynamically by adding proxy envoy sidecar container into our containers manifest file. Then finally it reaches the persisted etcd and scheduled. Then it spins up two containers running inside it. One is of our application or manifest file, and second is of envoy sidecar proxy container. So how this looks: submission, engineer or CI/CD pipeline sends a standard, that is a standard deployment manifest containing only our application container, to the Kubernetes API server. Then interception takes place, which is the API server passes the manifest to the Istio mutating webhook, which is Istio sidecar injector. Evaluation: the webhook checks if the target namespace has the label Istio injection is equals to enabled. Then mutation: if it is enabled, the webhook actively modifies the deployment configuration on the fly. It injects an init container to configure network routing rules via IP tables and the envoy proxy sidecar container definition directly into the pod specification. Execution: the API server stores this expanded mutated configuration. When the kubelet runs the pod, it starts up with both our application container and the sidecar container running side by side automatically. So that is it for the video today. If you have any doubts or questions, do let me know in the comments. Thanks. Have a good day. Bye.